Hi, so for today we're going to talk about inverse Laplace transform, and this is still a part of our study or lecture playlist all about advanced engineering mathematics. So let's get started. So for today's video, we're going to solve several examples involving how to solve inverse Laplace, okay, excluding the inverse Laplace, including partial fraction. So there is a separate video that I'm going to do on how we are going to get the inverse Laplace transform that involves partial fraction. But for today's video, let's focus on the inverse Laplace transform, basic inverse Laplace. So as you all know, in studying inverse Laplace transform, we must be familiarized with the different formulas involving on how we are going to get the Laplace transform of a certain function. Okay, so we must memorize those formulas so that when we apply inverse Laplace, it would be easier for us to at least somehow have an idea on what we are going to do with the inverse Laplace transform. So let's take a look at this example for the first problem. What is the inverse Laplace of the 2 over s raised to 5? So one property is that we can always factor out the constant outside of the Laplace, inverse Laplace. So we have 1 over s raised to 5. So, and we know that if we have a t raised to n, okay, the Laplace transform of this t raised to n, okay, would always be n factorial over s raised to n plus 1. So, meaning, if we are going to get the inverse Laplace of 1 over s raised to 5, our n here is 5. Okay? So, our n here in this case is 4, I mean, because this is the n plus 1. So, 5 is equals to n plus 1, getting n is 4. So, what will happen here is that the numerator should have a 4 factorial because our n here is 4. So what are we going to do is we must multiply this function, okay, by the 4 factorial over 4 factorial. By doing that, we are simply multiplying 1 to the whole function, which would not affect our Laplace transform. Okay? So what will happen here is we're going to let this 4 factorial inside the Laplace transform. So that would be 2 over 4 factorial. Okay. The inverse Laplace of the 4 factorial over s raised to 5. Okay. So technically, this is now t raised to 4. Okay. The Laplace transform of t raised to 4. Because if we get the Laplace transform t raised to 4, that's 4 factorial over s raised to 4 plus 1, which is, this is 4 factorial over s raised to 5. Okay, which is this. So we can say that this should be 2 over 4 factorial. Again, 4 factorial over 4 factorial is equal to 1. So technically, we are multiplying the whole function here by 1. So that is valid. That is valid. Okay? So what will happen is we have now inverse Laplace of this is simply t raised to 4. So we have 2 over 4 factorial. And 4 factorial is 1 times 2 is 2, 2 times 3 is 6. Okay? 6 times 4 is 24. Okay? 4 factorial is 24. So times t raised to 4. So 2 over 24, that would be 1 over, divide both sides or divide by 2. So you have lowest term, we have 1 over 12t raised to 4. So this is our function in terms of t. That's the inverse Laplace transform of 2 over s raised to 5. Okay, let's try another example. So for number 2, okay, for number 2 we have try to get the inverse Laplace transform of the following. We have 6 over s minus 1 over s minus 8 plus 4 over s minus 3. Okay, so this is very simple. Again, we can transfer or distribute the inverse Laplace sign. Okay, that's one property of our inverse Laplace. Since this is subtraction and addition, we can distribute that. So we have inverse of 4 over s minus 3. So if you can remember, one property again of Laplace is we can factor out the constant. So we have 6 inverse Laplace of the 1 over s minus inverse Laplace of 1 over s minus 8 plus 4 inverse Laplace of 1 over s minus 3. So with this, we don't have problem with this. Why? Because 1 over s, the inverse Laplace of that, is simply what? Okay, that is simply Laplace transform, inverse Laplace transform of 1 over s, that's simply 1. So 6 times 1 minus 1 over s minus 8. If you wish to recall, the Laplace transform of e raised to at, that is equivalent to 1 over s minus 8. Wherein our a here, okay, is 8. So what will happen, this inverse Laplace would be equivalent to e, okay, raised to 8t, okay, plus 4 times the inverse Laplace of 1 over s minus 3, that is e raised to 3t. So we have an answer that is 6 minus e raised to 8t plus 4e raised to 3t. So this is our inverse Laplace, our original function in terms of t. So as you can see, it involves still, you should memorize still the different formulas for Laplace transform, such as for the exponential, okay, in order for you to solve some inverse Laplace transform. So for number 3, what are we going to do for number 3 is to find the Laplace, inverse Laplace, okay, of 10 over s plus 2 minus 1 over 3s minus 5 plus a 7 over s raised to 5. Okay, again, applying the property of inverse Laplace. Again, I can distribute the inverse Laplace here. Oops. So we have inverse Laplace with 1 over s plus 2, because I factored out already the 10, minus inverse Laplace of 1 over 3s minus 5 plus 7 inverse Laplace of 1 over s raised to 5. Okay? So what will happen here is that 10 inverse Laplace, I know that this is readily available for inverse Laplace transformation. So that is simply e raised to 2t. So, but let's take a look at first on the second term. Okay? So we have a 3 here, okay, in our s minus 5. So I could not easily get 3 because they are not common factors. But what can I do here is simply, okay, factor out 3, because if I can factor out 3 outside of the inverse Laplace, then this would be reduced into some exponential function, okay, in the original function in the Laplace. So if I'm going to factor out 3, so s minus 5 over 3, I should offset 5 or divided by 3 on the negative 5, because this is still the same. If I'm going to distribute this, that is 3s minus 5, given that I offset, divide it by 3 on the negative 5 side. Okay? So, this denominator is equal to this, except that I factored out 3, but we need to compensate 3 again. Okay? So, plus a 7 Laplace, inverse Laplace of 1 over s raised to 5. So, again, 10 inverse Laplace of this is e raised to 2t. Okay? 10 e raised to, that is negative because this is plus. A while ago, okay? A while ago, we have 1 over s minus a, that is equivalent to e raised to at. If this becomes plus, okay? 1 over s plus a, that should be e raised to negative 18. So since this is plus, so that is negative 2. Okay? Minus, I can factor out the 3. Okay? 1/3. 1/3 inverse Laplace of the 1 over s minus 5 over 3. Plus, okay, in this inverse, since this is 5 minus 1, we have 4 factorial. I can, what? Multiply both sides or multiply and divide, okay, 4 factorial. So, in order for this Laplace, inverse Laplace transform to become 4 factorial, so that it is readily available for transformation into its inverse. Okay, so did you get this for this term? Okay, I both multiply by 4 factorial and 4 factorial divided by 4 factorial, and that is basically technically equal to 1. So this is still equal to this. Okay, if I'm going to multiply it by 4 factorial over 4 factorial. So I hope you get what I'm trying to say, so that this would be readily uh, can be transformed directly. So we have 10 e raised to negative 2t, and then we have negative 1/3 minus 1/3. Okay, since this is 1 over s minus 5/3, so that is e raised to 5/3 t. Okay, so this is minus, this is plus, so this would be na minus, this would be plus in the exponent based on our table of Laplace. Okay, plus 7 over 24. 4 factorial is 24. Okay, and this would be what? This would be t raised to 4. Simply t raised to 4 because we have 4 factorial over s raised to 4 plus 1 is s raised to 5. So we have the inverse Laplace as the following. Again, what we did is to apply some basic concept of Laplace transform, inverse Laplace. We factored out some of the constant that can be factored out outside of the inverse. And then we use the formulas for tables of Laplace in order for us to evaluate the inverse Laplace. Okay? So in this example, this is a very basic example. So I hope you followed what I'm trying to say here. Okay? So again, let's try again another example. Oops. Let's try again another example by inserting another page here. So we have number 4. So let's try another example. We have inverse Laplace of 6 over s squared plus 25 plus 3 over s squared. Okay, 6s, I mean s squared plus 25. Okay. So we already know that we can distribute the Laplace, inverse Laplace sign. Since this would make our problem a lot easier if we distribute it. And we can factor out some constants. So we have 6 inverse Laplace of s over s squared plus 25 plus 3 inverse Laplace of 1 over s squared plus 25. So as you can see, this Laplace transform is technically equal to what if we are going to evaluate this. So if we wish to recall, okay, the Laplace transform of, let's say, cosine of at, where a is any constant, if we get the Laplace transform of that, that is simply equal to s over s squared plus a squared, and which is exactly the same as this. And if we recall also, the Laplace transform of sine 80, that is what? A over s squared plus a squared. So which looks like exactly as this, but we have a missing a here. Okay? So what will happen is that we have to evaluate, or we have to get the value of a here. So obviously, This 25 is a squared. So we have s, this is 25a squared. So that is s squared plus, that is equivalent also to 5 squared. Okay? So plus 3, okay, take a look at this. 1 over s squared plus 25. So there is no s here. So this should be signed because of the plus. Okay? But the problem is we don't have a here. Okay? We don't have the a. So what I'm going to do is I'm going to multiply this both sides. Okay? Multiply and divide by 5 over 5. So that this 5 I can let it inside the numerator. So we have 5 over s squared plus 25. So this would be replaced by 1. Okay. So and we can now get the inverse Laplace of this. So what will happen? We have 6 cosine of a. Our a is 5. So this is 6 cosine 5t. This whole thing. Plus 3 over 5. Okay, 3 times 1 fifth is 3 fifths. So this is sine because this is a over s squared plus a squared. Our a here is 5 also. This 25 is already a squared. So the a is equal to 5. So and that is sine 5t. So this is how we get the inverse Laplace for this problem. So as you can see, we have set some values. We multiply and divide by 1. That is still basically 1 to meet the requirements for the inverse Laplace. So as you can see from the original problem, we have 1 over s squared plus 25. We cannot evaluate this directly because there is something missing. The a is missing here. And this should be 5. So we ought to multiply and divide, okay, by 5 over 5. So this is what we did. Okay. So the numerator is advanced here inside the inverse Laplace. So to satisfy this sine of 80, which is our a, should be 5. Okay. So let's try again another problem. What problem is that? Number 4, number 5, problem number 5. Yeah. Take the inverse Laplace of 8 over 3s squared plus 12 plus 3 over s squared minus 49. Okay? So again, applying the simple properties of Laplace, what can we do here is to simply, we have 8 inverse Laplace of 1 over 3s squared plus 12 plus 3. Okay? We have inverse Laplace of 1 over s squared, okay, minus 49. And again, in this denominator, oops, let me just rewrite this clearly. So we have 3s squared plus 12. We can still factor out 3, 1/3 on this denominator. So we have 8 inverse Laplace. We have of 1 over 3 times s squared, okay, plus 4. Okay. So plus 3 inverse Laplace of 1 over s squared minus 49. By the way, this is already minus. So it indicates that this should be hyperbolic sign because the hyperbolic sign of inverse Laplace of hyperbolic sign would be a over s squared minus a squared. So I can factor out 8 times 1/3. Okay, I can factor out 1/3. The inverse Laplace now of, we have 1 over s squared plus 4. Okay, plus 3 inverse Laplace of 1 over s squared minus 49. So how do we again compute this? Okay, we know that again this is s squared plus 4 and we have a 1 here. So again, this is a sign, okay, a simple sign. So the problem is we have to have an A here. So A. Okay? And our A in this case is 2 because this is already A squared. So where will we get 2 to put it here? By here, we can factor out 8 third. We can again borrow out from the 8 here in our numerator. So what will happen? Okay, so if we borrow 2 here, so this would become 2 times 4. That is still 8 over 3. Inverse Laplace of 1 over s squared plus 4. Okay, plus 3 inverse Laplace. How about in this? Our a in this case is what? Is 7. Because this is already a squared, so 49. So we can multiply it by both factorial 7 factorial. Okay. I mean, multiply both not by factorial, by 7. Okay, 7 over 7, which is still technically equal to 1. Okay, 1 over s squared minus 49. So what will happen next is, okay, I can let this 4 inside. Okay, let me just rewrite this and erase this. So this would be 2. Okay. So again, we got the 4 from the 8. 4 times 2. So I let the 4, or I mean, that's wrong. Okay. We let the 2 here. Okay. Okay. And then we have 4 here. Because this needs, the numerator of this inverse Laplace needs to be 2 because of our value of a, which is equal to 2. Okay. So what will happen? And again, this 7 over 7, okay, I can let this 7 inside here, and 1 over this would be left with 1 over 7. Okay, and this 1 over 7, I can factor it out outside of the Laplace, inverse Laplace. So that would be 3 times 1 over 7, 3 over 7, inverse Laplace. So now I can easily get the inverse Laplace of this. So that is 4 thirds. This is now what? Sine, of which the value of a is 2. So that is sine 2t plus 3 over 7, okay? Hyperbolic sine. This is hyperbolic sine because we have a minus, okay? S squared minus a squared. So that's a hyperbolic sine. Okay, let me just rewrite this. Please forgive me for my penmanship here. So we have hyperbolic sine of 7t. So this should be our answer for evaluating the inverse Laplace of this given uh, problem. Okay, so it's very if you are new to solving inverse Laplace, you may find it really hard. Okay, uh, but eventually, if you're going to practice more, solving more problems involving Laplace, then definitely you will be uh, become better in solving this topic. In this topic. Okay, so let's try another one. So for number 6, we shall try what is the inverse Laplace of 6s minus 5 over s squared plus 7. Okay. Again, we can this given function, okay, we can separate it. So we have 6s over s squared plus 7. Okay, that's minus inverse Laplace of 5 over s squared plus 7 plus 7. Okay, so what will happen here? Again, I can factor out 6. Okay, and then evaluate 1 over s squared plus a 7. Then we have, I can factor a 5. That's the inverse Laplace of 1 over s squared plus 7. Okay, we have an s here. I'm so sorry. So this should not be 1. This should be s. So again, this is a cosine because we have an s in the numerator and the value of our a squared is 7. So our a squared is 7 and our a should be square root of 7, okay, in this given. So we can easily what? Evaluate the Laplace of this, right? And how about for the second term? So this should be sine. So what will happen is that we don't have we should have the value of a here. Our value of a squared here is 7. The value of a is square root of 7. So we must have an a here. Okay? So we are going to, this is, let me just rewrite. Okay. So this is gonna be, we can multiply square root of 7 over square root of 7. So we have 5 over square root of 7, of which the another square root of 7 in the numerator, we will multiply it inside the inverse Laplace so that we can evaluate its inverse. So what will happen here? 6 inverse Laplace of this would be 6, okay? Cosine of square root of 7t. Remember that this is cosine at and the value of a is square root of 7 since this given value is already a squared. Minus 5 over square root of 7. Okay, this is again sine of square root 7t. Okay, this whole term. Okay, so that's it. That must be our answer for this given example. Okay, so let's try another one. So for number 7, find the inverse Laplace of 2s minus 9 over s squared plus 2. This should be easy. Okay, inverse Laplace of 2s over s squared plus 2. We can do that again. Minus, I can factor out now the constant. Okay, so inverse Laplace of, oops, I'm sorry, of 1 over s squared plus 2. So what will happen here, I can also factor out 2, okay, outside. So we are left with this. So again, our a here is 2. A squared is 2. Our a is square root of 2. Our a squared is 2. So the a here is square root of 2. Okay, the same as this. Our a squared here is 2. Our a is square root of 2. So the difference is this is cosine of s over s squared plus 2. So that would be 2 cosine of 80, which is square root of 2. Okay, minus 9 multiplied by this. This is sine. Okay, so we have to offset square root of 2 over square root of 2. So we have 9 over square root of 2. And then we have square root of 2 in the numerator. Okay, again. So we multiply and divide by square root of 2 over square root of 2. So we have sine of square root of 2t. So that should be our answer for this problem. Pretty easy, right? If you know the uh, formulas. Okay. So for our last problem, okay, for basic inverse Laplace. So let's try. We have 7 over s raised to 4 minus 5 over s cubed minus 6 over s squared minus 8 over s. Okay. So we can actually what? If you are good enough, so what will happen is we can mental it. Okay. So we have, okay, let's just rewrite first. 7 over s raised to 4 minus inverse Laplace of 5 over s cubed minus inverse Laplace of 6 over s squared minus inverse Laplace of 8 over s. So I can factor out the constants. So we have 1 over s raised to 4. Let me just replace this by simple parentheses. So we have inverse Laplace of, 5 inverse Laplace of 1 over s cubed minus 6 inverse Laplace of 1 over s squared minus 8 inverse Laplace of 1 over s. So, what we're going to do, so this is s raised to 4, so we must have a 3 factorial here. This is s cubed, 2 factorial on the numerator, squared, 1 factorial on the numerator, which is readily available here. Okay, so 1 over s, this is simply 1. Okay, so we have what? 7 over 3 factorial. Then we have Laplace transform of 3 factorial over s raised to 4. We have 5 over 2 factorial inverse Laplace of 2 factorial over s cubed minus 6 over 1 factorial of the inverse Laplace of 1 factorial, which is also equal to 1, s squared, minus 8 Laplace, inverse Laplace transform of 1 over s. So our answer would be 3 factorials, 1 times 2 times 3 is 7 over 6. This is t cubed, okay? Minus 5 over 2 factorial, which is 2. And this is a t squared, okay? Whatever the value of the factorial, okay, this would be our exponent in the t. So minus 6, this is obvious t, okay, minus 8. So this should be our answer for our last problem involving inverse Laplace transform. So I hope you learned something for today's video. This is evaluating inverse Laplace basic example. So for the next video, we will be tackling about inverse Laplace that involves partial fractions. So thank you so much for listening, and I hope you learned something from this video. So don't forget to subscribe to my channel for more math and engineering tutorials. Thank you so much, and God bless you.